Hello there, Mr. Sutton here with a lesson on rational exponents. You might wonder what this is doing in a chapter on radicals. After all, these are exponents, but it turns out we're going to be converting back and forth between radical and rational exponent form in just a little bit, and we'll also perform some operations with rational exponents. For your warm-up, see if you can evaluate the following. Pause the video and try it. First one, square root of 64. That's what I have to square to get 64. That would be 8. This next one is what I have to raise to the third power to get 64. That would be 4. And this last one, the sixth root of 64, that's what I have to raise to the sixth power to get 64. And that's going to be 2. So in general then, the rth root of x, this is what I have to raise to the r power in order to get x. So it's all about raising something to the power that's the index of the root. Now, it turns out that rational exponents and radicals are really pretty much the same thing. Here's how you can convert from one to the other. If you start with a rational exponent of p over r, so a fractional exponent, this r down in the denominator of your exponent, that is actually the type of root that you are taking. And this p is a power that you can raise all that to. Now, another way of writing this is if you have the p inside the root, you can still write this as the p over r power. So either of these notations works. So to summarize, the power goes on top, the root goes on the bottom. Hey, what part of a tree are roots on? The bottom. Where's the power in a corporate building? It's at the top. I mean, that's how I remember it. Pick whatever works for you. Right now, we're going to use that conversion formula to evaluate some constants that are being raised to fractional exponents. First thing we need to do is convert to radical form. So we can rewrite this as the cube root of 8, because the root is on the bottom of the fraction, raised to the fifth power. Now you might be wondering, well, what do I do first? It looks here like you have to do the root first and then the power. In fact, you can do them in any order that you want, because they really are both exponents when you get right down to it, so they are the same step. Having said that, I usually find it easier to do the root first. So the cube root of 8, that'll be 2. And then raising 2 to the fifth power, we've got 32. Now, I think that's easier than trying to figure out what 8 to the fifth power is, which is going to be a very large number, and then trying to take the cube root of an insanely large number. All right, pause the video and try this next one on your own. Did you convert to radical form? Let's see how you did. This will be the fifth root of 243 raised to the fourth power. Fifth root of 243, that's going to be 3. And then 3 to the fourth, that'll be 81. Now we're going to go ahead and try to simplify some variables that have fractional exponents. The key here is you're going to use all of your old exponent rules, but you're going to do it with fractions instead of integers. Now that is a little bit of a game changer, but let's take it one step at a time here. This one, we're multiplying bases. So remember, multiplying bases means we have to add the exponents together. So this is really x to the 4 over 16 minus 7 fourths plus 21 over 8. Adding fractions together, remember, we need an LCD for that. And in this case, that's going to be 16. That's the smallest number that all three denominators go into. So let's turn all of these into 16s on the bottom. To do that on our second fraction, we need to multiply the top and the bottom by 4. So that'll be minus 28 over 16. And for the last fraction, we have to multiply by 2. So 42 over 16. Combining these now, that's going to be, let's see, we're just doing this with the numerators, right? So that's going to be negative 24 plus 42. That's going to be positive 18 over 16. And then just like with any fraction, we should reduce if we can. So we can reduce this to x to the 9 over 8. Alrighty, try this next one on your own. Now when we're dividing bases, you might remember that we need to subtract the exponents. So this is x to the 12 thirds minus 7 ninths. Again, we need an LCD. This one, it's even easier than the last one. It's just going to be 9. Both of these go into 9. So 12 thirds can be rewritten as 36 over 9. Subtracting those now, that's going to be 29 over 9, which we can't reduce any further. For this next example, we have to use two exponent rules. Since we have things inside of parentheses that are being multiplied or divided, everything in here is going to get raised to the power outside. Exponents distribute, you could say, over multiplication and division. Now the other piece of this, after we raise both of these to the 30th power, when you raise one power to another, you're really multiplying the powers. So we've got 4/15 times 30. 30 over 15 is 2, so that's really going to be 4 times 2, or x to the 8th. And over here we've got a third of 30, which is 10. We'll do one more problem here. Pause the video and see if you can figure out how to do this one. Hopefully you tried converting this to fractional exponent form before combining anything. So we've got x to the 4/5, and this next one will be x to the 1/9. We need an LCD if we're going to add these together. LCD for this one is going to be 45. So that's going to be 36 over 45 plus 5 over 45. So we've got 41 over 45. And we can't go any better than that. That's it for rational exponents. Until next time, this is Mr. Sutton signing off.